Hey, welcome again back to Mr. Nelson's chemistry class. We're doing stoichiometry right now, and it's mass to mass. Practice sheet number 4, problem number 3. So again, when we do this, we have to remember the steps that we have to do. So we have to start off with balancing or getting a skeleton equation or an unbalanced chemical equation, and then balancing that. Now we do that so we can get the molar ratio. So when we start our stoichiometry, when we go from our number of grams of one substance to the number of grams of a different substance, we're going to have to use that molar ratio and that balanced chemical equation in order to get that. So let's go ahead and look at the question. And it says magnesium in the presence of sodium fluoride reacts to create magnesium fluoride in sodium metal. So if we start with 5.5 grams of magnesium, how many grams of sodium metal will be produced? Now, the first thing we have to do is we have to balance the chemical equation. So let's go ahead and start off at the beginning again. Magnesium, so we're going to go ahead and put in magnesium. Our symbol for magnesium, if we just look at our periodic table, is Mg. Okay, in the presence of sodium fluoride. Now, in order to do the nomenclature for sodium fluoride, we have to have the charges. And the reason is because we have a metal and a non-metal, which means that it's going to be ionic compound. There's no Roman numeral in here, so we know that it's a type 1. It's not polyatomic because it ends in "ide", and it's fluoride, and this is just the element. So we have to look at sodium and fluoride. So let's go ahead and go to our periodic table in our packet. And if we get to our periodic table on our packet, we see that we have sodiums over here in column 1A. So that means it'd rather give up that one electron and become the +1 in our chlorine on the other side, or fluorine, excuse me, is in 7A, which means that it has 7 valence electrons and it needs one more. So it's going to take the one from here, one from sodium, and it's going to be happy with those 8 valence electrons. So let's go ahead and go back to this, and we have sodium. We said that it is going to be a +1 because it has 1 valence electron. Fluorine has 7, but it wants to take 1, so it's going to be a -1. So again, because these numbers cancel each other out, we don't have to crisscross. So we just go ahead and write down one of each one. So our magnesium metal plus our sodium, which is Na, and fluorine is F. So there we go. There's our first part. There's our reactants. Now again, whenever we have anything by itself, we have magnesium, we have to say, is magnesium diatomic? Okay. Well, hopefully you remember what they are, but remember, the diatomic elements are the 7 diatomic elements. Make a 7 on the periodic table. So it's nitrogen, oxygen, fluorine, chlorine, bromine, iodine, plus hydrogen. Well, we're talking about magnesium metal, so it's not part of those 7, so it's not diatomic. So we can just leave it alone. Now, again, that's going to create magnesium fluoride. Now, magnesium, we have to know what the charge of magnesium. So let's go back to our period. Magnesium's in column 2A. So that means it loses 2 electrons. So it's a +2. So let's go back to that. And we're going to put in right here a +2. Our fluorine, on the other hand, was a -1. And we can get that right up from there. So that's a -1. Now this time they do not cancel each other out. So that means we have to crisscross. So we're going to put a 1 right here. And we're going to put a 2 over here. So that means I'm going to put in my magnesium, which is Mg. I only need 1, so we're not going to put a subscript. And then I have fluorine, but I need 2, so we're going to put a subscript of 2. Now that is going to also leave us with sodium metal, Na, and we get that from the other side. Now again, sodium metal is all by itself, so we have to ask ourselves, is it diatomic? Again, go back to the periodic table. Is it part of the 7 that are here, the 6 that are here, creating the 7 and there? No, it's not. It's over here, so it is not diatomic. So we can just leave it as it is. So now we have the unbalanced chemical equation, or the skeleton equation. So we need to go ahead and balance this out. And so we're going to write our magnesium, our sodium, and our fluorine, and how many we have of each one. So our magnesium, we have 1. Our sodium, we have 1. And our fluorine, we have 1. Okay, so we have one of each. Now we go to the other side. We're going to put in our magnesium. We have no subscript, so that means we have 1. We're going to put in our sodium. No subscript, so we have 1. And we're going to put in our fluorine. We do have a subscript fluorine, and that's a 2, so that means that we have 2 fluorines. So what are we going to do first? The only thing that we can do first is our fluorine. So I have to get 2 fluorines on this side. So the only way to do that is to change the subscript, or the coefficient. Remember, we cannot change subscripts. So we're going to put a 2 in there, which gives us 2 fluorines. So now we have 2 fluorines. Okay. Our problem is that it also changed our sodiums. So we're going to come over here and we're going to change our sodium to a 2. And so I have to chase it to the other side. Since I only have 1, I can't change the subscript because it's not diatomic. So we're going to put a 2 in there. So now I have 2 sodiums there. And we'll put a 2 there and get rid of this. So now we look like we're balanced. So I have 1 magnesium, 2 sodiums, 2 sodiums, 2 fluorines, 2 fluorines. Let's double check on the problem up here. So I have 1 magnesium, that's good, and 1 magnesium. I have 2 sodiums here, and I have 2 sodiums there, that's good. Fluorine, I have 1 fluorine 2 times, and I have 2 fluorines over here, okay, right there. So they're balanced. So my molar ratio is going to be a 1 to 2 to 1 to 2. So there we go. There's our molar ratio. So now we have to go ahead and, again, I want you to highlight or change the color and make it bold so we're nice and good. So our next step is we got to start our stoichiometry problem. In our stoichiometry problem, we're going to start with the number that's in the problem. In this case, there's only one number, so we don't have to worry about it. So there's our number, 5.5 grams. So we're going to come down here and we're going to say that we have 5.5 grams of magnesium. Now, so I can put that right up here, and I like doing this because I know where I'm going. So where am I going? It says how many grams of sodium metal, so I have to go over here to sodium metal. And so the question is, how many grams of sodium metal do we have? Okay, so I'm going from here to there. So we start off with this, and in order to go from here to there, it's 1 mole equals 2 moles. But I have to have it in moles first. So we have to convert it from grams to moles. And the easiest way is, again, look at our stoichiometry map at the end of our packet. And here's our stoichiometry map. We're going to go from mass in grams to moles by putting the number of moles of this first substance over the molar mass. And then we're going to use our molar ratio. And then we're going to do just the opposite to create the back to the mass and change it from moles to mass. So let's go back to the problem. So we're going to put our times, and we know that we're going to put 1 mole of magnesium on the top. And then on the bottom, we're going to put the molar mass of magnesium. Well, it's just magnesium, so we have to go to our periodic table, find what the atomic number is. And once we get the atomic number of magnesium, which is not the atomic number, but the atomic weight, excuse me, is 24. So that's what we're going to use. So we're going to use the weight of 24 grams equals that 1 mole of magnesium. So now I can go ahead and put my times, and we're going to next we're going to do our molar ratio. Now our molar ratio is going to be 1 mole of magnesium to 2 moles of sodium. So since I have moles of magnesium here, we're going to put moles of magnesium on the bottom. So we're going to put 1 mole of magnesium, and we're looking for the one, and that one goes on top. So we're going to put 2 moles of sodium on top. Okay, so, and I'm going to just go ahead and underline these because I know that they need to be underlined because I have a top and a bottom. But we're going to go ahead and put our times. And now we have to go from moles back to grams. So when I get rid of moles, that means I have to put moles in the bottom. And 1 mole of sodium equals the molar mass of sodium. And the molar mass of sodium is going to be in grams, so grams of sodium. Now I have to figure out what is the grams of sodium. I believe it's 23. Okay, but let's see if that's correct. So let's go ahead and look back at the periodic table, and we see sodium. So the weight of sodium is 23, so that's correct. So we're going to put that in there. Now, before we go ahead, we know that the answer is going to be in grams of sodium because that's what we need. It says how many grams of sodium metal. But if I lift it like this, I would have to put all those units in there. But remember, we can cancel things out. So if I have anything on top and on bottom, I can get rid of it. So I have grams of magnesium here that I can get rid of because I have grams of magnesium on the bottom. Now again, if I had them both on the top, I couldn't get rid of them. So you got to make sure this helps double check where we're at. So I have moles of magnesium up here and moles of magnesium down here. I have moles of sodium up here, and I have moles of sodium down here. So now I got rid of everything. The only unit I have left is grams of sodium, and that's what the original problem has. So from this point, all I really have to do is the math. So again, we multiply by the top, divide by the bottom. If there's ones, we don't have to do it because remember, ones do not, if I multiply or divide by 1, it doesn't change the value. So all we have to do is do everything that's a number other than 1. So we're going to start off with our 5.5. We're going to divide that by 24. We're going to multiply that by 2, and then we're going to multiply that by 23. And that's going to equal 10.541. 10.541, and I believe it's repeating sixes. But we're not done because we can only be as accurate as any number that's in our original problem. So we go ahead and look at how many significant figures we have. Well, we have 2 numbers there, so we have to have it in 2 significant figures. So we put our decimal right here, and we look after that, and we see 5. Well, 5's unique, but there's something after the 5, so that means that we round up. So we're going to get rid of all this, round this up to 11, and now we're done. So 11 grams of sodium will result, and I need to go ahead and highlight that. And that's it. We figured out our best answer, and that's how we do it. For practice number 4, problem number 3. Hey, that sheet's done. We're on to practice number 5. Hey, we're getting close to the end. Hey, good luck on the rest of them. Hey, as always, go Mohawks, and Nelson out.